Welcome to part 5 of factoring by magic squares. In this example, you can see we now have more complex variables. And I'm sure in your class, you guys are going to look at a lot of different details of the different situations of what can be factored, what can't be factored. I'm just going to focus on the technique of the magic square in this video. So again, we're just going to look at writing down the coefficients. So 4, 28, and 49. Okay. And I'm going to figure out this magic square. Then I'll go back and worry about the variables. Okay. Now, again, you may have talked about it in your classes. You might be recognizing this as the form of something special. So I'm going to go ahead and make the guess of 2 and 2 over here. Okay. And 2 and 2 multiply to 4, so that's good. For 49, I could do 1 and 49. Or I could try 7 and 7. I'm going to do that. 2 times 7 is 14. 2 times 7 is 14. 14 plus 14 is 28. Yay! So now I can read across, and I'm going to have 2 and 7 in here, and 2 and 7. And in your classes, you'll talk more about how this is a perfect square trinomial and all that business. But I do want to take a moment to say, okay, now how do these variables relate to what we did here in the magic square? Well, this is the x squared, right? This is the y squared. And this is the xy. So because this is the x squared, each of these are the values of x. This is the y squared. Each of these are the value of y. And that makes sense because 2x times 2x is 4x squared. And 7y times 7y is 7y squared. And 2x times 7y is 14xy. So when you have something that's x squared, xy, y squared in that format, it translates like this. So if this is the x squared column, then each of these are going to be the x's. If this is the y squared column, these are going to be the y's. And as I said, you'll talk a lot more in your classes about when you can factor something, when you can't, what the variables have to do, common factoring out other variables, and other tricky situations. But I hope these videos have given you a good idea of the method of magic square factoring.